In today's installment of Ask Your Meteorologist, I am here with Adam Sherwinski, and we are going to build a cloud in a bottle. But first, let me ask you the question, Adam. What are clouds?
So clouds are just basically areas of condensation, moisture in the sky. I mean, that's what you see. When you see fog, that's a cloud on the ground here at different layers of the atmosphere. And so there's your, we can make this at home, which is kind of cool to see. Now, it's not as robust as a cumulonimbus cloud or stratus clouds, but some of the things that you'll need are a can of hairspray for your cloud condensation nuclei. That's a fancy word. You can say 10 times fast.
Sounds very fancy.
A mason jar with a lid, obviously, and then ice. Ice. And some warm water. Not boiling, but really close to that level.
Very, very warm water.
Very warm water. So we're going to start out. We're going to have the warm water first.
Okay.
I'm going to have you pour it in there.
Pour it into there. How much?
About 1/3 of a cup, if you can. If not, it doesn't have to be exact. A little bit more.
How's that? More?
That'll work. All right. And we're going to swish it around a little bit. Oh, yeah, it's pretty warm. Swish it around a little bit. Get the sides a little bit more on the warm side of things.
Ooh.
There we go.
Is there like a secret to it? Is it a special swishing?
No. It gets the sides of the walls of the jar a little bit warmer too as well. That should help make our cloud form a little bit better as well. All right. And then next we're going to add in ice. You're ahead of it.
I was going to say I'm ready with the hairspray.
You're so ready with the hairspray.
Okay.
So basically the ice is acting as a way to kind of like, the upper levels of the atmosphere are cooler. At the surface you got a warm moisture, so it's going to rise. You'll see a little bit of that kind of condensation start to happen on the sides here. Again, condensation. What is that? That's literally when we have water start to collect on colder surfaces. Okay. So you see that on your windows. You see that on glasses of water in the summertime. So.
And I have another question. So we talked about tornadoes last week. Is this how tornadoes form?
That's a very different process. We'll get into probably during severe weather season, but some of the basic elements are in here, though. Again, we're going to have that. Okay, we're going to.
Because you can also create a tornado in a bottle. I was reading online, right?
Yes, and that's a different process.
I was going to say we'll have to do that during severe weather season.
So we're going to let it sit for a little bit here.
Okay, I see some condensation forming here on the bottle.
Condensation to go again. So let's see.
And then what's going to happen when we spray this? Is it a chemical reaction? Is it
So it's not a chemical reaction. It just adds for cloud condensation nuclei. To get a cloud, yes, you need moisture, but also you need that moisture to latch onto something. Cloud condensation nuclei. And in nature and outside in the atmosphere, usually it's ash from smoke or dust sometimes can act as it. And we're using hairspray. You can use pollen. There's other tiny little more materials that collect onto and conglom on. You get enough of that, and that's how you get clouds.
And that explains, I feel like, why the marine layer and there's so much clouds in LA when there's smog, or New York where there's smog. It's always cloudy because there's a lot of particles, I guess, for it to hold on to.
You can get that, or you can get some of the haze as well. Let's see.
Is it time?
It's about that time.
I'm ready with the spray.
All right, go ahead and spray it.
Okay, a lot.
As much, just go. All right.
Ooh, look at that.
All right, and then we're gonna close her up. We're gonna wait. Okay.
Okay.
We're gonna wait a little bit and see. And you can kind of see.
You can kind of see it in the center too.
Yeah, you can kind of see it trying to spill out and escape a little bit here, but you can kind of see a little bit more of the up and down undulations there.
Right.
As it rises, it starts to sink and sink and rise and sink and rise. But over time, it's gonna kind of condense a little bit here. It's not super thick. It's not like a puffy white cloud, but you start to get a little bit of it there.
Yeah, you can see the almost like smog essentially.
Yeah, it's very similar to that process. And then I'm gonna let go.
What kind of cloud would this be?
Our jar cloud.
A jar cloud? Oh, okay.
This not really a fancy
This isn't
term.
like an alto stratus.
No. So right now it's kind of making that little tiny cloud. Right now it's got that cloud condensation nuclei. It's got the warm water at the base. And?
Here, wait, should we show all sides?
Yeah, there we go.
There we go. Oh, look at that. You can see it better from that angle, I feel like.
At some point you got to let things be free, right?
Yeah,
if you love it, you got to set it free, right?
Should we set the cloud free?
3, 2, 1. There we go.
Oh, look at that.
There we go.
I feel like when I was a kid on airplanes, I always used to think it was so cool when we were like flying through the cloud. You can actually put your hand in a cloud in a jar at home.
Yeah, that's the thing. Clouds aren't solid, obviously. They're liquids, but there is some turbulence within some of those clouds. So whenever people are skydiving, they're like, hey, don't aim for the clouds.
Of course.
A little bit of turbulence in some of those, even some of the smaller clouds. So again, they're a little bit heavy too. I mean, there is some mass to clouds. I don't remember the exact number, but they're heavier than people. They're not light and fluffy.
It's not feathery. feather light. You would imagine it would be feather light.
With all that water in the atmosphere. So, yeah, at home, try this. It's a cool little experiment. Might keep the kids entertained. And
definitely.
Look at that.
That was fun. Well, thank you for teaching me how to do this and for coming on Ask Your Meteorologist. And if you have a question for Adam, you can reach out to him at asherwinski@wcia.com.